Welcome to this explainer. Today, we're tackling an absolute powerhouse of a structural tool in software engineering, the Decorator Design Pattern. Look, if you've ever found yourself completely bogged down by inflexible code that just keeps growing and growing, well, you're in the right place. We're going to see exactly how to add responsibilities to your objects dynamically, on the fly. Okay, let's dive into this. You know the drill, right? It's a classic software architecture dilemma. You build a perfectly simple, clean class. It's beautiful. But then, the business requirements change. Users suddenly want feature A or feature B, or maybe they want both A and B, or neither. So what does this all mean for us? How on earth do you give your objects all these new capabilities without completely destroying your codebase and having to write literally thousands of new classes? Well, here's our roadmap for figuring that out. First, we'll look at the class explosion problem. Then, wrapping objects dynamically, the architectural blueprint, and a Java implementation. Finally, we'll compare design patterns and wrap up with summary and key takeaways. All right, section 1, the class explosion problem.
Imagine this real-world scenario. You're building a system for a local coffee shop. Naturally, customers start by ordering a base drink, right? An espresso, a latte, maybe a cappuccino. But let's be real. Nobody just orders a plain black coffee anymore. They want milk, sugar, a pump of caramel, maybe a dash of vanilla, until it's basically a milkshake. The point is, they want complete, unconstrained freedom to customize their drink. Now, if we rely on standard, rigid inheritance to solve this, oh boy, our class diagram turns into an absolute nightmare, and fast. You start with a base coffee class, and you make an espresso subclass. Easy enough, right? But then you need an espresso with milk class, and an espresso with sugar class. And then a customer walks in who wants both, so you have to write an espresso with milk and sugar class. You see where this is going? Every single new combination forces you to write a brand new subclass. Your inheritance tree just starts compounding exponentially. It spreads like wildfire.
Just to emphasize the absolute insanity of this approach, let's say you have just 10 optional toppings. The math tells us that 2 to the power of 10 equals 1,024. You would literally have to write over 1,000 subclasses just to handle the combinations of 10 simple toppings for one single type of coffee. No way. That's what we call the class explosion problem. We desperately need a better way to handle this.
Which brings us to section 2, wrapping objects dynamically.
Let's check out the formal definition here. The decorator pattern allows additional responsibilities to be attached to an object dynamically without changing its class. Now, I really want you to focus on those two specific parts. Dynamically, meaning at runtime, and without changing its class, meaning we don't have to touch our original, battle-tested base code at all. And this brilliantly illustrates the core concept. Instead of creating a subclass for every single combo, we use a metaphor of wrapping. Think of it like this. You start with your simple base component, a dark coffee. Then you wrap it in a milk decorator object. Boom, that adds the milk behavior. Then you wrap that whole thing in a sugar decorator. Then maybe a chocolate decorator. Each wrapper adds exactly one responsibility, sequentially, without fundamentally altering that original coffee object sitting right there in the middle. And you know, it's important to know this isn't just some gimmick for coffee shop apps. This pattern is literally everywhere. Think about a pizza ordering system where you dynamically wrap a base pizza with cheese, mushroom, or olive decorators, or a car configurator where you're adding GPS, leather seats, and a sunroof at runtime. It's even huge in cybersecurity. You can take a basic email object, wrap it with encryption, wrap that with compression, and finally wrap the whole shebang with a digital signature. All right, section 3, the architectural blueprint. Before we get into the exact architecture, let's quickly preload your brain with the 4 distinct roles that construct this pattern. First up, you need a component interface. That's the common ground for everything. Second, the concrete component, the actual base object you want to decorate. Third, the abstract decorator wrapper itself. And fourth, the specific concrete decorators. These are the guys that actually add the new behaviors. Now, what's really interesting about this slide is the abstract decorator class right there in the middle. Notice how it has 2 relationship arrows pointing back to the component interface. The solid diamond arrow means it has a component. That's our composition. It literally stores a reference to a wrapped component. But the dashed triangle arrow means it also implements the component interface. That's realization. This dual nature is the absolute secret sauce of this pattern. Because the decorator is a component and has a component, decorators can wrap other decorators completely interchangeably. It's kind of like nesting dolls. Moving on to section 4, implementation in Java. Let's see how this translates into our high-level Java structure. You can see those 4 roles we just talked about mapped out perfectly. We've got our coffee interface, we have our espresso concrete component, and then we have the abstract coffee decorator. Notice how the coffee decorator implements coffee, but inside its constructor, it actually requires you to pass in a coffee object, which it stores in a protected variable. So it acts as a middleman, right? Just delegating requests to a whatever coffee component it happens to be holding at the time. Now, looking at the actual implementation, specifically the main client code, look how effortlessly this reads. We say coffee coffee equals new espresso. Right now it's just espresso. The cost is $3.50. Next line, coffee equals new milk decorator coffee. We just took the original object, passed it into the milk wrapper, and reassigned it. Now the cost logic dynamically adds $80. Then we do coffee equals new sugar decorator coffee. The cost adds another $20. When we finally call get description or get cost, the request drills all the way down through those wrappers and literally bubbles back up, calculating a total of $4.50. And the best part, 0 subclasses required. Next up, section 5, comparing design patterns. Okay, here is the core aha moment. Inheritance creates rigid relationships at compile time. Every single combination requires a hard-coded subclass. But the decorator pattern, it relies on composition to create incredibly flexible combinations of objects at runtime. You get to choose exactly what features to combine on the fly while the program is actively running. Now, it's also absolutely vital to differentiate decorator from a very similar structural pattern, the proxy pattern. While they might look structurally similar because they both wrap objects, their intents are complete opposites. Actually, scratch that. It's more like they serve entirely different masters. A decorator focuses on enhancing an object, adding new responsibilities and features like adding that milk to our coffee. A proxy, on the other hand, controls access to an object. It acts as a surrogate for things like security, lazy loading, or remote access. Basically, decorator means enhancement, while proxy means protection. Finally, section 6, summary and key takeaways. We all know that in the real world, every pattern has trade-offs. Now, the advantages of decorator are massive. Incredible runtime flexibility, completely preventing that class explosion we talked about, and strict adherence to the open-closed principle, meaning your base classes are closed for modification but totally open for extension. However, be careful, because the disadvantages are very real too. It can result in lots of tiny, highly specific decorator classes just polluting your directory. Also, wrapping order can unexpectedly matter if you aren't paying close attention. And let's be honest, debugging can be an absolute headache when you have to step through 5 layers of wrappers just to find the original object. So, the crucial point is this. The decorator pattern allows us to champion composition over inheritance. Just like stacking toppings on a pizza or stirring ingredients into a coffee, decorators add value one by one exactly as you need them. And most importantly, they do all of this while keeping your existing foundational code completely untouched and perfectly safe. Which leaves us with one final question for you to consider today. I want you to look at the projects you're working on right now. Where are you relying heavily on massive, bloated inheritance trees just to handle a few optional features? And how might you refactor that rigid structure using the flexible compositional power of the decorator pattern? Something to think about! Thanks so much for joining me on this explainer, and happy coding.